Op de Cebit worden allerlei nieuwe technologieën gedemonstreerd. En dan heb ik het niet alleen over computers en grafische kaarten, maar dan heb ik het echt over ook medische mogelijkheden. En hier krijg ik echt onmiddellijk het Terminator gevoel van, de T800 met die arm. Maar dit is dus een prothese en dat is eigenlijk een robotarm die met de hersenen kan aangestuurd worden. En hier voor mij staat professor Mark Franke. En die gaat mij wat dingen uitleggen hierover, over hoe deze arm precies werkt. En dat gaan we in het Engels doen.
It's a prototype of a so-called neural prosthesis. And this artificial hand is biologically inspired. It is nearly similar to the human hand. It uses some kind of skeleton and tendons to be controlled. And we control it by nerve signals. And right now we take those nerve signals from animals. We had an experiment with a crab, Cancer pagurus, and the rat, Rattus norvegicus. And in both cases we inserted some kind of microelectrode into the nerve of the animal. And then the nerve grew through it and the axons regenerated through the electrode. And then we were able to measure the signals from the electrodes and interpret them and analyze them. And we did this by using a so-called artificial neural network. It is a self-learning algorithm that can identify clusters by itself. And it identified the clusters of the different signal types within the nerve signal in a learning phase. And then we were able to assign certain actions to those clusters because the rat and the crab couldn't tell us what they intended to do. And so we assigned actions by ourselves. And these actions are used to control the artificial hand.
Okay, but at this moment, if I have no arm and I put this thing on me, we don't have the correct instructions yet to move it. For instance, if I say I want to open my hand, at this point it's not possible yet to open it because the system still has to learn which command I give via my brain, right?
Yes, it needs a certain time to learn the signals, to separate the different signal types. This might be about, I don't know, in this case we had 6,000 cycles, 6,000 different signal types to learn it, to train it. Wow. When we apply to a human being what we are planning right now, we might need some more training cycles, maybe about 50,000 or 100,000, but the principle will be the same. The system learns what kind of signals go through the nerve because we don't actually think what kind of information we send down there. It's done by the body, by the skeletal motoric. And so it learns it and then we have to assign what kind of motion or action was intended within every cluster.
And how many of those electrodes are necessary to put in my nerve system before I can...
In the case of the experiment we had one electrode with about 20 wires that were let out, and every single electrode on the implant has space for about 5 to 10 axons that generate through it. So when we apply it to the human being, I think we might need at least about a couple of 100 electrodes inside.
Okay, and how strong is this hand? Will this hand make me more powerful than a normal human would?
I think maybe not more powerful, it depends on the training. We are able to carry 10 kilograms per finger with this artificial hand, and I think this is a quite good range for a human being. I think it doesn't need more.
Okay, and how much does it weigh? Because it can be pretty heavy maybe, or is it lightweight? Or?
It can't be too heavy because it's too uncomfortable to carry too many kilograms on your stump when you're amputee. Yeah. So we reduced the weight and now we are about 1.2 kilograms, and I think this is a rather good weight. It should be lighter actually, but we need this amount.
Yeah. Okay. And when do you expect that this is finished? When you expect that people really can use this?
Well, it definitely depends on when the study starts. We have all the partners on board. We have hand surgeons. We have a prosthetic service provider who cares about the stump of this prothesis. And we have our technology on board, and it depends actually when the fund is available for us.